Hey guys, we are back on YouTube after I think, decade-long hiatus now. Wow. But those who are OG to the channel remember the sensational Chubby Bunny Challenge and the FIFA gameplay. Those were the days. But we are back, and as you read in the title of the video, I'm going to be showing you guys how I made this cool little watch here. Let's do it. So I first got the idea to make a watch last summer, and originally I was going to use an OLED screen as the watch's display, a Arduino Nano as the watch's microcontroller, and a real-time clock module to keep track of time. And mind you, this was all going to go on top of a breadboard with a bunch of wires. And I quickly realized that it probably was not going to fit on my wrist. So I decided to design my own PCB on KiCad, and previously I didn't have much experience making PCBs, but I learned on the go through a couple YouTube videos and a bunch of Google searches. But while I was designing the PCB, I was thinking, like, if I'm going to be making all these custom pieces, why not make the watch look cooler? Because no hate to OLED screens, but they're kind of boring. And I wanted something that looked futuristic yet vintage at the same time. And that's when I came across these cool Nixie tubes. I knew I was going to use these tubes from the first time I saw them because of how crazy they looked. For you history buffs out there, Nixie tubes were invented in the 1930s, and they became pretty prevalent in scientific and industrial equipment, especially during the Cold War. NASA actually used Nixie tubes in their spaceships for their calibration displays during the Apollo 11 mission, which is pretty cool. Sadly though, Nixie tubes became pretty obsolete with the rise of LEDs in the 1970s, and right now there is around 30,000 tubes left in circulation. So these were pretty expensive, but hey, I think they're worth it because they look pretty sick. It's funny because when I came across Nixie tubes for the first time, I feel like I started seeing them everywhere, especially in pop culture. Like I watched Oppenheimer and they were in the atomic bomb sequence, which is pretty cool. I think it's called the Bader-Meinhof effect, when you learn about something and you just start seeing it everywhere. But I digress. You might be asking, how do Nixie tubes work? So a Nixie tube is what you call a gas discharge tube because it's filled with invisible gases, namely neon, argon, and mercury. And if we look at the dissected Nixie tube here, we have the gases inside the tube, and the digits are just bent metal wires, and they act as the cathode, or negatively charged terminal. Now, wrapped around the stack of digits is a metal mesh, or cage, and it acts as the anode, or positively charged terminal. Now, when a high enough voltage hits the positive anode and the digit cathode, the atoms of the gas inside the glass tube split into positively charged ions and negatively charged electrons, making a sort of soup of hot plasma. It's Ramadan, all I can think about is food, my bad. But anyways, the positive ions are pulled towards the negative cathode, and the negative electrons are pulled towards the positive anode. And it's this movement of charged particles that allows the electric current to flow through the tube and light it up. But here's the thing. Nixie tubes light up at around 170 volts, but my microcontroller runs at 5 volts. Yeah. So I had to spend a lot of time getting the right parts for the watch to ensure that the voltage would be fine for all the components. Now let's take you to the lab to show you all the parts I used for the watch. Alright guys, welcome to the lab. We're in the garage, of course. Let me take you through a bit of the equipment I used. So we have a soldering iron, a fume extractor, that's a must, a hot air gun, solder, flux, soldering wick, a bunch of tweezers and screwdrivers. I also used isopropyl alcohol to clean out the flux, a lot of components for the watch, the PCBs, and that's pretty much it. So I got my PCBs printed from PCBWay, and the watch case and the glass were made from a vendor in Ukraine. He had a CNC machine, so he was able to cut the glass, and he also had a 3D resin printer for the watch case. And while soldering this, like the crazy Russian hacker says, safety is #1 priority. So I had the fume extractor running at all times. This is a necessity if you're soldering. And I always had gloves and usually had a mask on because solder, if you may not know, has lead. And lead fumes are highly carcinogenic, so probably want to limit your exposure to them. And after a long 3 days of soldering, I had finished the watch. It was awesome seeing it work, but of course, there were some issues we ran into to get to that place. Mostly with this infamous charging module. Let me explain. So I use this module to ensure that the watch's battery recharges efficiently, and it does this by following a charging cycle like this one. And the module protects my battery from discharging below 2.7 volts, which is like a healthy minimum voltage level. And it also protects it from overcharging above 4.2 volts. And most rechargeable devices like laptops and phones, they use charging modules like these. So I knew I needed one for my watch, but what I didn't realize is that I only had space on the watch for the main chip and not the module as a whole. So I had to figure out how to desolder the chip or take it out from the module, which was a struggle to say the least. I ended up burning 3 out of the 4 modules I had, and I waited for my hot air gun to come in to try out the 4th module, which worked. Hooray. But then I realized that these chips have polarity, like how batteries have like a plus and minus side. And let's just say I kind of melted the polarity indicator on my chip. So I had to test my luck by soldering the chip in different positions, no diddy. But eventually I got the watch to charge, and that was the icing on the cake. After that, the watch was finished. Here's the final result. I think it looks pretty cool. So I made this video mostly to give you guys an idea of what it takes to build a project like this from start to finish. But more importantly, I want to help you guys with your projects. So if you have any questions at all, you can comment down below. And I left all my social media links in the description as well. And if you're curious about this project, I also made a GitHub repository. That's also in the description. It'll have all the data sheets, my code, and extra information about how I built this watch. Appreciate y'all. I'll see you.